So I just received these samples from ARRIS Composites, and I gotta say this is the nicest sample bag I've ever seen. Some kind of felt, stitched, printed bag. I don't know what I would ever use it for, but it sure is nice. I got a few samples here I just wanted to talk about because it's a really cool technology that I was not aware of until the last couple weeks. I thought I'd bring it to you, and maybe you can use it in one of your projects. So composite materials are really interesting. They usually have a sort of a resin material and a fiber material. And most people are familiar with carbon fiber composites that have a sort of an epoxy in the carbon fiber filaments, and they come in sheets, and you can, different weaves and different blends, and you can shape them and form them using vacuum and epoxy to get the shapes that you need. It's a thermoset process. You can't change the shape once it's done. But there are also materials out there that are a little bit different, and this is a thermoplastic composite material. So this is a thermoplastic. It's a nylon material with carbon fiber continuous filaments running through it, which means that I could heat this and reform it and reshape it, which is kind of a cool idea. So what they start with is we're going to call it a pre-mold, for lack of a better word. In the injection blow molding industry, it's a pre-mold. You start with one geometry that isn't your final geometry, but it's easy to manufacture, and then you have your final molded geometry. So when they're making the pre-mold, ARRIS takes something called toe preg, which the analogy would be pre-preg carbon fiber filament or carbon fiber sheet, where the sheet or the toe is pre-impregnated with epoxy. In this case, the toe preg, or the carbon fiber toe or the carbon fiber string, is impregnated with thermoplastic, in this case nylon material. They take the toe preg and they wind it around a form or mandrel to get a, let's call it 80% complete geometry that kind of looks like this part, or kind of looks like this thin part. But it's not necessarily formed in this way, but we're getting the nylon material impregnated around the carbon fiber toe, and we're using that to place the carbon fiber filaments into the shape and in the direction where we need the stress, or we want to react the stress. So in this case, I saw a picture of the pre-mold. I did not get a sample of the pre-mold, but really what it is a flat piece that has this form factor. It's more like a rough shape because they're hand winding the carbon fiber toe preg. That pre-mold piece goes into a tool that then compresses and squishes down and forms the final shape. So this is a very thin, about a 1 millimeter or half a millimeter nylon piece, and it's incredibly stiff for how thin it is. And that's because we have continuous fiber filaments running down the length and around and woven throughout all these openings. This would be like an insert for a shoe where you want a really lightweight sort of footbed liner or something. This piece looks like a bottle opener, I think. And the way that this works is, again, you wind the toe preg around these parts, and the final part looks almost like a compression molded or a forged carbon fiber part. If you look closely, carbon fiber forging is really not forging in the traditional sense like you forge metal, but it's usually taking sort of long leaf carbon fiber strands and mashing them into a tool with epoxy and using that to form a part. This one, you can see the continuous fibers sort of running around the end of this part and through this thin section. And I would say this is as stiff as any aluminum part that I could imagine, possibly even a steel part, but it weighs almost nothing. So super impressive little part here. Very, very interested to try to use this technology from ARRIS Composites. Lastly, a carabiner. You can see on the part some of the ejector pins and features that make it look like an injection molded part. But traditional injection molding, you would not be able to inject long fiber, continuous fiber filaments that would follow this shape. You'd have to use chopped fiber, which would give you some stiffness, but not nearly the stiffness you're going to get from a continuous fiber. Where I wonder if this would move to is some sort of a partnership with Markforged and their continuous fiber filament printer, because you could realistically 3D print a very close to net shape, maybe 90% net shape part with the continuous fiber filaments where you want them, and then compression mold that part to eliminate any of the aesthetic imperfections that come with a 3D printed part. So that might be kind of a cool hybrid approach where you build the pre-mold with a Markforged printer rather than manually winding the toe preg around the mandrel. Just kind of thinking through this. It's a very cool process. I think reforming and reshaping thermoplastics is a really interesting manufacturing technique in itself, because you can get geometry that isn't able to be formed with other technologies. So for example, if you, let's say you injection mold a part and then you can shape set it to create an undercut that wasn't moldable, or that would have had a very expensive side action or something like that. So think about reforming and reshaping as a secondary op in your manufacturing processes, particularly when you're looking for something stiff and light, like these parts from ARRIS composites. So happy to talk about this more if anybody has any questions, but I'm looking for applications for this technology. I think it's super interesting.